Hello class, this is Mr. Hammond. He's an astronomer from right here in Bloomington, and he's here to show us how he uses angles in his everyday job.
Hello class, how are you doing today?
Good.
Well, as you probably already know, angles are all around us. You may not think about it, but everything with straight edges and corners is a right angle. Well, in astronomy, we use angles to measure different types of things. Angles can tell us the size of an object in the sky and also mark its direct position. Now, I will ask who has questions. You may ask me questions, just shout them out and I'll try to answer them for you.
Does traveling around the sun have anything to do with angles?
That's a very good question. Yes, it does. We travel 360 degrees around the sun each year. This is a full circle. So with 365 degrees in each year, this tells us roughly how long we will travel. You might ask why this is used. We can't say that it's 1 degree because there are 365 days, but it is almost 360 degrees, which would make it 1 degree a day. So we use the angle to tell how long we travel per day, and this will tell us how long it will take to get halfway around the sun, and other times of the year how long it will take to do that. It also gives us insight on how long it will be until there are equinoxes and eclipses.
Wait, so what exactly is an equinox?
This is also a good question. Equinoxes happen twice a year, and basically this is the amount of time, this is the time of year when the time of day and the night are the exact same. So it'll be light out and it'll be dark out for the exact same amount of time, which is 12 hours in a day.
Thanks.
What about an eclipse?
An eclipse. An eclipse, there are two types of eclipses. A solar eclipse is when the sun, the earth gets between the sun and the moon so that you can't see it. And then a lunar eclipse, which is when the moon gets between the sun and the earth so that you can't see the moon because it's not directly getting light from the sun.
I have another question.
Yeah, what's that?
Can you use supplementary, like complementary angles in like astronomy, or apply it in there somehow?
Yes. Yes, it's more likely that we would use supplementary angles than complementary angles. As you guys already know, a supplementary angle, or a pair of supplementary angles, is two angles that measure to be 180 degrees. So like when we're traveling around the sun, halfway around the sun would be 180 degrees because that's half of 360. So if we've traveled so far in a year, we've traveled so many degrees. Like let's say we've traveled, 85 degrees around, 85 degrees. So that means we have another 95 degrees before we make our supplementary angle, which would have to be 180 degrees. That's half your year. Any more questions?
Yes. Do angles play a part in how much of the sky you can see from a certain place on Earth?
This is a very good question. Yes, we do use angles to tell how much of the sky we can see from a certain place on Earth. No matter where you are on Earth, you can see about 50% of the sky. So as you move closer to the equator, you see more and more of the sky until you get to the equator. And if you're at the equator, you can basically see all of the sky throughout the entire year. So, basically you would say that yes, the angles do tell you how far from the equator you are, which would depend on how much of the sky you can see. So yes, to answer your question, it does determine, angles do help you determine that. What other questions?
I got another question.
Alright.
So me and my dad, we talk about like phase angles in reference to space most of the time because he's like in NASA and stuff. Does this actually have anything to do with astronomy? Because, it's like, I don't know, but if so, like, what is it?
Yeah, a phase angle has everything to do with astronomy, basically. It's when viewing an object from space, we use the light from the sun that provides a view of the object. So the sun reflects towards that object, and that allows us to see part of the object. So we're on Earth, and the angle that object makes from us to the sun, that's your phase angle. This angle shows us how much light will be on that object for us to view from the Earth.
Yeah, how big is the phase angle in degrees?
A phase angle can be anywhere from 0 to 180 degrees, depending on how close or how far the object is from Earth. For some objects, such as the planet of Mars, the maximum phase angle is 45 degrees, but it just all depends on where the object is in space.
So with this given thing, we can actually use angles to determine like distances between two objects in space?
Yes, that is correct. By using imaginary lines between the two objects, we have an angle from Earth. This will help us create a triangle, And using that triangle, we can use trigonometry to figure out some of the relative distances between the objects.
What is the most important thing that using angles in astronomy can help astronomers do?
I mean, this is an opinion. It's a matter of opinion, whatever you think. But I would say that it helps us determine angular distance between two stars or objects. And an angular distance is the distance between two objects that we can see. So,
Why is this important?
it's important because angular distance allows you to measure by staying in one spot. And we're going to stay in one spot on the Earth. So all you have to do is pick a point from one side to the other side of the object and measure the angle between the two directions of the point. Or if you want to look at the angular distance between two stars from point 1 to point 2, then point at the other and measure the angle between the two directions of pointing. Because stars can be at different distances away from us, two stars that are relatively small angular distance, they may be physically farther from each other than two stars that have a large angular distance between them. So for example, if the angle between the two objects is small, then they could be very, very far apart. But if it's a bigger angle, then chances are those two objects will be closer together.
Can angles be used to measure the distance around a star or the Earth?
I mean, not really anymore today, but like this was extremely important before we had formulas for a lot of things. Like I'll give you the example of Eratosthenes. Eratosthenes was a Greek mathematician and astronomer, and he used angles of shadows created by light from the sun to tell what the distance around the Earth was, which allowed him to figure out the circumference. He figured out that the angle between Alexandria and Cyrene, which are two places in northern Africa close to there, their distances from the sun and from each other at noon when the sun was shining on them was 7 degrees. So by using this degree and having the distance between those two places, and he did know the distance between those two places, he was able to use trigonometry to figure out the circumference of the Earth. And I mean, this wouldn't be done today, as we have a simple formula to do this, find the circumferences of objects and other things. But it was very important, and it was pretty impressive that he could figure that out himself way back when.
Okay, class, let's thank Mr. Brown for being here today and taking time to answer questions for us.
All right.
Thanks, Mr. Brown.
Thanks, Mr. Brown.
You are
Appreciate
very
the,
welcome.
questions.
You are very welcome. If you guys have any more questions, I'd be willing to answer them at other times. Thank you very much. You guys have a good day.